Assalamualaikum and hi everyone. With this video, we'll cover topic 14, thermodynamic. For this topic, we have three subtopics, which is 14.1, first law of thermodynamic, 14.2, thermodynamic process, and 14.3, thermodynamic work. This is a learning outcome for this topic. So this video will cover 14.1. So 14.1. So at the end of this topic, you should be able to state the first law of thermodynamics. Q is equal to delta U plus W. And the second one is solve problem related to first law of thermodynamics. Okay, before we proceed to first law of thermodynamics, so we look at thermodynamics mean. Thermodynamics is the study of how energy can be exchanged between a system and its surrounding. The system can exchange energy in two general ways, which is as a heats or works. So this will affect the microscopic properties like pressure, volume, and temperature. So first law of thermodynamics states that heat supply to a closed system is equal to the increase in the internal energy delta U of the system plus the work done by the system on its surrounding. So mathematically, we can write it as Q is equal to delta U plus W, where the delta U is the change in internal energy. So that means U final minus U initial. Q is represent the heat and W is work done by the system. Okay, from the previous slide, so we know that the first law of thermodynamics has the equation is Q is equal to delta U plus W. So this is sign convention for Q, delta U, and W. So, okay, so we look at one by one. Okay, Q. So Q will become positive when the system is absorb heat or heat flow into the system. And Q will become negative when the system is lose heat or heat flow out of the system. Okay, so delta U will become positive when U is increased. So how do we know the U is increased? It depends on T, because we know that U is directly proportional to T, temperature. So when the temperature is increased, so U is increased. So delta U become positive. And when the U is decreased, so delta U will become negative. Okay, so work done. Okay, so work done. Work done will become positive. Work done positive. Work done positive when work done by the system or the system is expand, which mean what is expand? So volume. So volume final is greater than volume initial. Okay, so work done negative when work done on the system. So work done on the system, or we also can say that when the system is undergo compression. Compression mean volume final is less than volume initial. So less than volume initial. So before you solve the question for this topic, so you must make sure that you use the correct sign. Okay, before we proceed to example, so we look at the detailed explanation for change in internal energy. So we know that the previous slide, delta U is directly proportional to T. So when temperature change, so internal energy also change. Okay, so delta U positive when the delta U will become positive when indicates that the increasing in temperature. When T is increased, so delta U will become positive. Okay, so delta U will become negative when temperature is decreased. Okay, another information you must know that when the temperature is constant, so no change in internal energy. So when temperature is constant, delta U will become 0. And delta and delta U also depends on initial and final state. It does not depend on path taken. So for example, you can see the diagram. You can see this diagram. So we know that the path taken for this is from A to B. So we have six path taken here. So we have a path taken 1, 2, 3, 4, 5, 6. So for this the delta U is same. Delta U is same because the delta U is not depend on path taken. It's only depends on initial and state final state only. Okay, so for then in the system, okay, so work done on or by a gas is depend on the path taken. It's different from the delta U. So that if the delta U is not depend on the path taken, but the work done is depend on the path taken because work done is represented by the area under the line curve in PV graph. So it will be explained more detail in subtopic 14.3. Okay, so we know that so work done will become positive if the volume is increased. That means if volume final is more than volume initial, so work done will become positive or work done by the gas. Okay, so if the volume final is less than volume initial, so work done is become negative. So you must remember this for you to answer the question. Okay, let's look at the first example for this topic, for this subtopic. Okay, so we have 100 joule of work is done on a system. Internal energy increased by 74 joule. Does the gas system gain or lose heat and how much? Okay, so from the question, we know that the question asks you to find heat. Okay, so heat, what is the heat? Okay, so given information is 100 joule of work is done on the system. So that's mean the work done is negative. So negative 100 joule. Okay, another information is 74 joule. So internal energy increased by 74 joule. So that means delta U is positive 74 joule. Okay, so positive 74 joule. So how to find heat? So we use the first law of thermodynamic formula, which is Q is equal to delta U plus W. So delta U plus W. So we just substitute all the information given. So we have delta U is 74 minus 100. So 74 minus 100. So we got the answer is negative 26 joule. So the unit is joule. Okay, so since we got the answer is negative, so that means the heat is lost. The heat is lost. The heat is lost. Okay, let's look at the second example. So we have 2,500 joule of heat is added to a system. Okay, and 1800 joule of work is done on the system. What is the change in internal energy? So the question asks you to find change in internal energy. So delta U. So what is the delta U? Okay, given information is 2500 joule of heat is added. So that means Q is positive. So positive 2500 joule, and also given information is 1800 joule of work is done. Is done on the system. So that's mean work done is negative 1800 joule. Okay, so using the first law of thermodynamic equation, so we have Q is equal to delta U plus W. So rearrange the formula. So we got delta U is equal to Q minus W. So just substitute all the information given. So we have 2500 joule minus 1800 joule. So we got, so after you calculate, so we got the answer is positive 4300 joule. Okay, let's look at the last example. So we have a gas expand under a constant temperature and thus work of 30 joule against the surrounding. So the question asks you what is the change in internal energy of the gas and find the amount of heat absorbed or lost by the gas. Okay. So from the question here, so we know that we have the work done of 30 joule. So we have work done is equal to positive 30 joule because the work done is work done by the system, or work done against by the surrounding is same to the work done by the system. Okay, so we have another information is constant temperature. Okay, so constant temperature. Okay, T constant. So T constant. So we have T constant. So A, the question asks you to find the change in internal energy. So delta U, what is the delta U? Since we know that delta U, U is directly proportional to T. So since T is constant, so that's mean delta U is equal to 0. So because there is no change in temperature, so delta U is 0. Okay, so B. So B, the question asks you to find the amount of heat. So that means the question asks you to find Q. Okay, so we just substitute in the first law of thermodynamic formula. So we have Q is equal to delta U plus W. So from the question A, we know that delta U is 0 plus positive work done. So we have the Q is equal to 30 joule. So that means since we have the Q is positive, so that means the heat is absorbed by the gas. So the heat is absorbed by the gas. Absorbed. Okay. So that's all for this topic 14.1. So we'll proceed to 14.2. Thank you.